In question number 5, we're provided with the following polynomial function, which is degree 3. Now, I do want to remind you about solutions to this polynomial functions. So what are the possible solutions? We could have 3 real zeros or solutions, and then if there was any imaginary, and if you want just a reminder, what does imaginary look like? It's going to contain an I, so something like this. If there is an imaginary, we will both have that imaginary. I'll give you an example, 2 plus 3i, and we'll have the conjugate of it. So imaginary solutions always come in pairs. So one possible solution here is 3 real solutions. Another possibility is we could have the one solution that's real, so 1 real, and we could have 2 imaginary, also known as complex solutions. Those are my possibilities. So how do I determine what it's going to be? Well, I already know one of the solutions, so I'm going to do synthetic division. You could also use long division in order to do this. So I'm going to put in 1, that's the coefficient of x cubed, negative 3 goes with x squared, positive 4 with x, and negative 12 goes with x to the 0. Now I know that my remainder at the end is 0 because it tells me that x equals 3 is a real 0. That means that the remainder is going to be 0. So synthetic division means drop down the first number. We're going to multiply and add down. In my class, we use the acronym MAMA. So multiply, add down, multiply, and add down. What do I do with this remainder at the very bottom? So 0 equals, this has no x's, 1x, and 2 x's. And I'm going to now solve this. 0 times x, well 0 times anything is 0. I'm going to subtract 4 to the opposite side. Dividing by 1 doesn't change anything. I'm going to take the square root knowing I'm going to have 2 answers, but I can't take the square root of a negative. The I comes out front, and the square root of just 4 is 2. So my solutions are 3, 2i, and negative 2i. Now let's look at our multiple choice options. We have exactly 1 distinct root of 3, and we have 2 non-zeros, imaginary complex. So exactly 1 distinct 0 and 2 non-real zeros. Correct answer is D.